This is a roadmap. It consists of four phases. First one is embedded C. Next one is microcontroller and embedded system. Next one is embedded programming on PAC 16F 877A. Fourth one is product implementation. This is our introduction. The project focuses on creating a virtual washing machine using Picsimlab. The aim is to replicate the functions of a real washing machine within a digital environment. The project entails delving into the various components, cycles, and functions of washing machine, which helps in developing and implementing control algorithms within Picsimlab to mimic real-world washing machine functionality, including managing water levels and timing of different cycles. These are the overview and goals of internship. The primary focus of this internship is to apply the acquired knowledge utilizing embedded C programming language to interface with various peripherals within a specific microcontroller. This involves a comprehensive study of the microcontroller's datasheet to understand its architecture and functionalities thoroughly. Finally, it is important to put this knowledge into practice by actively engaging in project work and gain proficiency in embedded systems development, enabling them to tackle real-world challenges in the field of embedded programming. These are the features of embedded C. First one is efficiency. It is highly efficient in terms of both memory usage and execution speed. Next one is access to hardware. Provides the features to directly access and control hardware peripherals. Next one is one of the main features, cross-platform support. It promotes cross-platform development by abstracting hardware-specific functionalities. Then interrupt handling. Embedded C supports interrupt handling mechanisms to respond to external events promptly. This is the last one, energy efficiency. Optimizes code for low power consumption, crucial for battery powered embedded systems. These are some of the C concepts that we have covered in embedded C. First one is number systems. Number systems are decimal, octal, hexadecimal, binary. Next one is data representation. First one is bit. A bit it is actually a smallest unit of data and can represent two states, typically 0 or 1. Next one is byte. It's composed of 8 bits. Bytes are fundamentals in C, and the most operations in C are performed on bytes or multiple of bytes. Next one is word. It's a term used to describe the natural unit of data that a processor can handle at once. In C, the size of word can vary depending on the architecture of the system. Common sizes include 16-bit, 32-bit, 64-bit words. The size of a word determines the maximum amount of data the processor can process in a single operation. Then next is data types. First one is integer. Under integers, char and int is coming. And under floating point, float and double. Modifiers. Modifiers are C keywords that modify the meaning of fundamental data types. Under modifiers, there are two types of coming, size and signedness. Under size, short, long, 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 and under the signedness, signed and unsigned. Next is qualifiers. Qualifier is a keyword that is applied to a type resulting in a qualified type, like constant and volatile are the examples for that. Next is conditional constructs. First one is if-else statements. If-else statements are performed when the operations should be based on some specific condition. Next is switch case. Evaluate expression, perform actions accordingly. Then while loop. This loop will continue until the condition is false. Do while it will repeat the actions based on conditions. Next for loop, it is just used for creating loops. Continue, skip remaining iterations in loop, and break. Use it to exit loop prematurely. Then the next are operators. Operators are of four types: arithmetic, logical, and relational bitwise. Arithmetic operators are sum, difference, multiplication, division, modulus. Then logical. This is not logical and logical or relation greater than, less than, greater than or equal to, less than or equal to, if equal to, not equal to. Bitwise are and, or, XOR, negation, etc. Then array. Array is a collection of elements with same type. That means if an array contains full of integers, then you can't include uh, of the type character or any other type than integer. Then pointers. Pointers are variables storing memory addresses in C. Functions, modular blocks of reusable code in C. Strings are arrays of characters terminated by null. Next is storage classes. It will define scope, lifetime, and visibility. Processor, it is actually directory for text manipulation in C. Next, we are going to the microcontroller part. The definition of microcontroller is it is an integrated circuit which is capable of being programmed to perform a specific task. First one is aspect. Here we have created a table showing difference between microprocessor and microcontroller. Uh, in terms of purpose, microprocessors are general purpose. Uh, uh, they're used for general purpose, and for microcontroller they are used in embedded systems. In terms of components, microprocessor requires external components, but in terms of microcontroller, everything is integrated in the board only. In terms of application, microprocessor need a high computation power, but in microcontroller, it is only used for specific tasks, so it only needs comparatively low computation power. Next, in terms of power consumption, microprocessors have generally a higher power consumption than microcontroller. Next, we are going to embedded systems. Embedded system is any combination of hardware and software which is intended to do a specific task can be called as an embedded system. Next is features. The features of embedded systems are real-time operation, low power consumption, compact size, integration of peripherals, task-specific for functionality, reliability, and robustness. Real-time operation. These are timely response to input signals or events. Then efficient energy usage or prolonged operation. Compact size is small-scale hardware integration for space efficiency. Integration of peripherals, onboard components for streamlined functionality, task-specific functionality, tailored operation for design tasks, reliability and robustness is it will give continuous and resilient performance in demanding environments. These are the categories of embedded systems: standalone embedded systems, real-time embedded systems, network embedded systems, mobile embedded systems. First one is standard embedded systems. Self-contained units executing tasks autonomously without external connections or communication requirements. Examples are microwaves and washing machine. So here they are using, here they are doing for washing machine. So here we are using we are making a standalone embedded system. Next is real-time embedded system. These are systems processing input promptly within predefined time constraints for critical operations. Example, anti-lock brake system, that is ABS, then pacemakers. Next is network embedded system. These are devices interconnected exchanging data with external entities through network protocol and interfaces. Examples. These are examples a smart thermostat. Next and last is mobile embedded systems. These are combat systems tailored for portable gadgets with restricted resources optimized for efficiency and mobility. Examples are smartphones, fitness trackers. These are the components of embedded system. First one is software. It provides instructions for the microcontroller or microprocessor. Next one is microcontroller or SoC or microprocessor. These are the CPU that execute software instructions. Then memory stores data and instructions for a microcontroller or microprocessor. Next is DAC and ADC. DAC is it converts detailed signals from microcontroller into analog signals. It is actually used to control actuators. Actuators examples are motors or servos and speakers that require analog input. Next is ADC. Converts analog signals from sensors. It enables microcontroller to process real world data. Next, actuators. Actuators perform physical actions based on process data. Example, motors and LEDs. Next is sensors. It provides input to the microcontroller for decision making. Then human interfaces. Allow interaction between humans and the embedded system. It actually provides feedback or accept user input. Then diagnostic port. It is used for testing and diagnosing issues within embedded system. It actually facilitates debugging and maintenance. Then FPGA or ASIC. FPGA full form is Field Programmable Gate Array. ASIC is Application Specific Integrated Circuit. So these are customizable chips that can be tailored for specific applications. FPGA is actually configurable logic block that allows designers to create custom digital circuits. SAP is designed specifically for a particular task, offering performance improvements. Then auxiliary system. It supports the main operations by providing necessary power and thermal management. And next I am giving to Shashank for explaining about PSM microcontroller.
Let's see the features of PSC16F87788 microcontroller. It is an 8-bit microcontroller manufactured by Microchip Technology. It has many features like flash memory, RAM, clock speed, from data memory, analog to digital converter, comparator, serial communication. It features 14 kilobytes of flash memory for data storage. The microcontroller has 360 bits of RAM. It operates at a maximum clock speed of 20 megahertz. The bit microcontroller includes 256 bytes of RAM data memory. It boasts 8 channels of 10-bit ADC for analog signal conversion. It equipped with two comparators and comparison bus. It has some serial communication boards like PSCRT, etc. There are some list of peripherals that are used in the microcontroller. They are like LED, digital keypad, CLCD display, and a fan and a bus. LED is a semiconductor device that emits light and electric current passes. This is the picture and representation of LED. We can call it a symbol, LED symbol. And let's look into about the digital keypad. ESC 16F8 double subnet controller seamlessly interface with digital keypads, remaining extreme components. Digital keypad consists of GPIO pins, that is general purpose input for pins. CLCD is like a LCD, it's a character LCD. Its peripheral allows interfacing its standard character-based LCD display to provide visual feedback or display information in embedded system. It supports both 4 bits and 8 bits data transfer modes. Uh, these are the functional requirements of the microcontroller of our project. Uh, we are using switch 5 to power on the washing machine and switch 6 to start or stop, or like, I mean, on or stop the washing machine. And we are using switch 5 to navigate through the options, and we are using switch 1 to open or close the door. These are all switch 5, switch 6, switch 4, switch 1 are the inputs, like inputs to the microcontroller. The microcontroller has some processing and gives the output using the CLCD, that is a display for interface, and buzzer and motor. These are the tools that we use to do this washing machine. We use the MPLAB and XC8 Compiler and Picsimlab Simulator. Let's see the various interface screens in our project. So this is the initial and starting screen. Initially, we show press key by to power on one. As I told before, we are going to use key by to switch on the machine. So if we just a single click on the key by is nothing but switch by. Uh, the washing machine will power and it will show a display like powering on washing machine, and then it gets started. And all these things will be displayed on the CLCD. There are many uh, programs of washing machine, like different types of washing. Uh, Here we can see a hashtag symbol. It helps us to navigate through the options. Mm, And there are many programs like daily wash, daily wash, liquid wash, whites, stain wash, eco cotton, washing, uh, woolens, bed sheets, rinse, dry only, wash only, tap wash, etc. If we want to select any of the programs, we have to long press switch over. And if we want to navigate through the uh, programs, we have to just see the function. So the washing program menu encapsulates a varieties of washing options by utilizing the keypad switch. Users can navigate between these options. Selecting a highlighted option means it is the option corresponds to the aspect is the highlighted option. The thing is achieved through the long pressing of switch. There are we can adjust our water level according to our wish. There are few options for adjusting water level like auto level of water, low level, medium, high, and extra level of water. This screen facilitates the user in selecting the water level. Uh, the water level menu presents the following operations. As I told before, auto, low, medium, high, and extra. These are the water level options that we have. And if we by using switch 4 we can navigate through these options by single press in the switch 4. And if we want to select any option that is beside the asterisk, we are to long press the switch 4. Let's hit our select screen interface. So next screen is auto stop screen. If where you if we want to start the washing, we have to click switch 5, and if we want to stop washing, we have to switch stop washing in the sense. Previously, we have set that the program type of program and water level. If we choose the menu anything by mistake, by clicking switch 6, we can go back and uh, we can say, select them according to our wish. After the washing program and water level has been selected, user will be presented with the option to commence the washing operation. Upon pressing switch 5, the machine will initiate, displaying the selected function along with the estimated duration. Subsequently, the interface will transform to the function screen for further interaction. So next one is the function screen. Once the washing machine is initiated, the current function is progress. Whether it be a wash, rinse, or spin, will be showcased on CLCD. Additionally, the remaining time of ongoing operation will be promptly displayed for user preference. So here we can see what type of function it is doing, operation is doing, and how much duration time we can see. And as I told before, we are using switch one to open or close the door. When the door is open, it tells us to please close the door. When the door is open, it stops humming. And this is the last screen interface. This is the completion status screen. Upon completion of all programs, a notification will be displayed on the CLCD, prompting users with the message program completed. Please remove the close. So when washing is completed, it shows like this interface like in the CLCD and notifies us to remove the close. Now I am handling to the yes. He will explain the code.
This is MPLAB XID. Using this, we will be writing code and compiling using XC8 Compiler, and it will be converted to a H file, which will further loaded into Picsimlab simulation for uh, simulation. Picsimlab for simulation. Then this is the main.c file. These are the header files that we have included for running of this program. These header files are for CLCD timers, Keypad, and XC compiler, and also for main.c, main.h. Then we are going to the main void main. This is the first function, init config. This function will basically initialize the keypad, CLCD, fan, and buzzer. This is that then we have declared character key and send character key. This is for this key will detect which switch is pressed, and next is CLCD function. It will basically print the string to the CLCD, and this is and also it can take input from which block it should start. Then the power on screen function. This will basically print a block. This first for loop is for printing the blocks on the line one. This these two statements are for printing power on second line, washing machine on line three, and again on line four it will print blocks, and we are giving delay of 1 second. Then just clear screen. Then it is entering the while one. Here the operation mode we have initialized as washing program display. So it will enter the first case washing program display. It will execute this function. Let's go to that function. Here, if we are pressing switch 4, it will navigate through the options. Uh, these are for the rotation of the options. Then we are going back to while one. So here, if we are pressing long switch 4 and operation mode is washing program display, we go back to the it. Uh, so it will select the option and it will update the operation mode as water level and reset mode also to water level reset. Then the next time it is entering the while one, it will execute this case water level. It will execute water level display key function. Here also, if you are pressing switch 4, it will linger on the water level index, which is basically navigate to option. Then these are for the rotation of the options. Then again the same thing. If you are long pressing switch 4 and operation mode is water level, it will set the time and also update the operation mode as a start stop screen. Then next time it is entering this while one. This case will be executed start of the Here, if you are pressing switch 5, it will start the program. That is, operation mode will be updated as start program. Otherwise, it will go back to the washing program display. That is, if you are pressing switch 6, it will go back to the washing program display. Here, if you are starting the program, it will run this function, the run program program function. Here we are going to run program function. Here, there is first step for the starter step. So static check means if you are pressing switch one, then it means the door is open. If it is open, then it will normally think as doors closed. So here, if you are pressing the switch 6, it will pause while running. If you are pressing the switch 6, it will pause the washing program. So the fan will off and also the timer will also pause. That's this is the explanation for our code. Next, we are going to the simulation part. For Picsimlab, as you can see here, the X file is already loaded into the Picsimlab. So as you can see in the display, if you are pressing key 5 to power on washing machine. So as the numbering we have done in the code, the numbering is like 1, 2, 3, 4, 5, 6, 7. So if you are pressing switch 5, it will go back to the it will go to power on washing machine. So RB for is our switch 5. We are clicking on that. So it will show powering on washing machine and go to the washing program. Then if you are simply pressing the switch 4, it will navigate through the options. So suppose we need to select whites we are selecting. So for selecting the whites, we have to long press the switch 4. That's RB3. So it went to the water level modes. So here we can choose here also if you are simply pressing the switch 4, it will navigate to the options. And if we need to select this water level mode, we can long press the switch 4. As you can see, if you are pressing switch 5, it will start the program. Otherwise, if you are pressing switch 6, it will go back to the washing program. That it will stop. So if you have mistakenly choose a washing program or virtual mode, you can go back to the washing program and again choose both of them. So for example, I am selecting switch 6. So it went to the washing program again. So here we are selecting go to heavy and we are selecting through long pressing switch 4. So water level also we can navigate through pressing switch 4. Then we can long press on that switch 4. So here we are started. After clicking switch 5, it started to wash. So let's wait for the washing to get over. So here also we have implemented switch 1 for the door status. So here the switch 1 is now open. That's RB0 is open. That means the door is closed. If you are pressing the switch one, it will consider as door is open. It will show please pause. The buzzer also will beep as you can hear. So it again started while releasing. Let's wait for the washing program to get over. There are three functions are there. Function. There are three functions of wash are there. That is wash, rinse, and spin. So at the 30-second, it went to the rinse mode, and at the third second, it will go to the spin mode. So at the fifth second, it will start spinning. So now you can see the program completed and remove close. And the buzzer also beeped for 2 seconds. So let's go to the conclusion part. So conclusion, utilizing the washing program simulation via Picsimlab proved instrumental in enhancing comprehension and practical application of embedded systems principle. This interactive tool not only deepened the theoretical understanding but also instilled invaluable hands-on experience, laying a robust groundwork for delving into the realm of automation and control systems. Thank you.